Let's get right into it. The hidden planet surprise. Imagine spending 11 years staring at the same patch of space, only to realize a planet had been hiding there the whole time. Sounds unbelievable, right? That's exactly what happened with Beta Pictoris d. Instead of spotting it during a brand new observation, astronomers uncovered it by re-examining years of archived telescope data. Even more impressive, they didn't just detect its presence. They directly captured the planet's own faint light. Here's the incredible part. Beta Pictoris d is about 100 times fainter than another directly imaged planet in the same star system, making it the faintest exoplanet ever directly photographed from Earth. That's an enormous challenge because a star's intense glare usually overwhelms the tiny amount of light reflected or emitted by nearby planets, making them almost impossible to see. And this discovery reveals something bigger than a single planet. It shows that groundbreaking discoveries don't always require brand new telescopes. Sometimes the answers are already hiding inside years of existing observations, waiting for better analysis techniques to uncover them. Think about that for a second. Somewhere in today's archived data, entirely new worlds could still be waiting for someone to find them. 6,000 new worlds. Not long ago, discovering even a single planet beyond our solar system was a dream. Today, that number has crossed an astonishing 6,000 confirmed exoplanets. Think about that for a second. Every one of those worlds orbits another star, and each has its own story. Some are scorching balls of lava. Others are giant gas worlds, and a few may even lie within the habitable zone where liquid water could exist. But here's the exciting part. The search is nowhere near over. Scientists have identified more than 8,000 additional exoplanet candidates that are still waiting to be confirmed. Each one must pass careful checks to rule out false signals before it officially joins the growing list. Space keeps reminding us that patience is just as important as powerful telescopes. And the numbers keep climbing. Missions like NASA's Kepler and TESS, along with the powerful James Webb Space Telescope, continue to transform our understanding of distant planetary systems. Every new confirmation expands the cosmic map a little further and raises the possibility that somewhere among those thousands of worlds, another planet may be surprisingly similar to our own. Hidden worlds in old data. Imagine spending years searching the sky for new planets, only to discover that one of them had already been sitting in your datum all along. Sounds like science fiction, but it's becoming reality. As image processing techniques improve, astronomers are finding exoplanets that older software simply couldn't, separate from the overwhelming glare of their parent stars. One remarkable example is Beta Pictoris d, which was uncovered after researchers reanalyzed 11 years of archived observations. The planet wasn't invisible because it wasn't there. It was invisible because the technology available at the time couldn't clearly reveal its incredibly faint light. Sometimes the biggest discovery isn't a new observation. It's a new way of looking. And that's changing how astronomy works. Instead of relying only on brand new telescopes, scientists are also revisiting massive archives collected over decades. Every improvement in data analysis has the potential to uncover worlds that were hiding in plain sight all along. Think about that. The next major planetary discovery could already exist inside data we've had for years, just waiting to be recognized. Sugar drifting through space. What if one of life's ingredients was floating through space long before Earth even existed? It sounds like science fiction, but astronomers have just detected the first true sugar ever confirmed in interstellar space. The molecule, called erythrulose, was found inside a giant cloud of gas and dust about 26,000 light-years away, near the center of the Milky Way. Here's why scientists are so excited. Erythrulose is a 4-carbon sugar, making it the most complex true sugar ever identified between the stars. It wasn't discovered on a planet or inside a comet, but in the vast space separating stars. Researchers identified it by matching its unique microwave fingerprint using highly sensitive radio telescopes in Spain. This doesn't mean we've found alien life, but it does strengthen a fascinating idea. If complex sugars can form naturally in interstellar clouds before stars and planets are even born, then some of life's building blocks may already be waiting when new worlds begin to form. Think about that for a second. The recipe for life might start long before a planet ever exists. The universe's oldest beacons. Imagine looking so far into space that you're actually seeing the universe when it was just 5% of its current age. That's exactly what astronomers achieved after discovering the oldest known quasars ever found. These extraordinary objects were already blazing across the cosmos only 670 million years after the Big Bang, their light taking more than 13 billion years to finally reach Earth. Here's the unbelievable part. Each of these ancient quasars shines with the brilliance of about 1 trillion suns. But they aren't stars at all. They're powered by supermassive black holes greedily pulling in enormous amounts of gas, releasing staggering amounts of energy. Using the Euclid Space Telescope, astronomers discovered 31 ancient quasars, more than doubling the number known from this early era of cosmic history. And that's where the mystery begins. According to current theories, black holes shouldn't have had enough time to grow this massive so soon after the Big Bang. Yet somehow, they did. Every one of these discoveries challenges our understanding of how the first galaxies and black holes formed. Sometimes, the oldest light in the universe doesn't answer our biggest questions. It creates entirely new ones. A movie of the universe. Imagine taking a single photograph so detailed that you could zoom in and spot millions of galaxies, then repeating that process every few nights for an entire decade. That's exactly what the Vera C. Rubin Observatory has begun doing. Armed with the world's largest digital astronomy camera at 3.2 billion pixels, it's starting an ambitious 10-year survey that will repeatedly scan the southern sky. But this isn't just about collecting beautiful pictures. By comparing each new image with the last, astronomers will create the first true time-lapse record of the night sky. They'll watch asteroids race across space, stars explode as supernovas, galaxies change over time, and countless cosmic events that were once easy to miss because the sky was never monitored this consistently. Here's the exciting part. Scientists expect this observatory to detect millions of previously unknown asteroids, uncover billions of galaxies, and capture countless rare cosmic events that last only hours or days. Think about that for a second. Instead of taking snapshots of the universe, we're finally starting to watch it move, change, and evolve, almost like a movie unfolding across the cosmos. The galaxy that lit the fog. Imagine trying to shine a flashlight through the thickest fog you've ever seen, and somehow the light escapes. That's exactly what stunned astronomers. Using the Hubble Space Telescope, they detected powerful ultraviolet light leaking from a galaxy that existed just 1.4 billion years after the Big Bang, something scientists never expected to observe from such an early era of the universe. The galaxy, known as MXDFZ 4.4, is much smaller than the Milky Way, but it's packed with tightly clustered young stars producing intense ultraviolet radiation. Those stars appear to have carved channels through the surrounding gas, allowing some of that energetic light to escape into space. This is the earliest confirmed example of this process ever observed. Why does that matter? In the universe's earliest days, space was filled with neutral hydrogen that acted like a giant cosmic fog, blocking ultraviolet light. Discoveries like this suggest galaxies such as MXDFZ 4.4 helped clear that fog during the era of reionization, transforming the universe from dark and opaque into the transparent cosmos we see today. Sometimes, one distant galaxy can illuminate an entire chapter of cosmic history. 11,000 new space rocks. Imagine discovering 11,000 new asteroids before your telescope's main mission has even officially begun. Sounds unreal, but that's exactly what happened at the Vera C. Rubin Observatory. Using just 6 weeks of early engineering observations, astronomers identified an astonishing number of previously unknown objects, proving the observatory was already performing far beyond expectations. And this is only the beginning. Scientists expect that once Rubin's full 10-year survey is in full swing, it could discover around 11,000 asteroids every 2 to 3 nights during its early years. Think about that. What once took astronomers decades to find may soon be uncovered in just days, transforming our understanding of the solar system faster than ever before. Until we meet again,